I am very pleased to welcome today nearly 50 registered participants. That is once again significantly more than we had participants last autumn when we had our first International Digital Day. And it shows me that today's topics are important for our industry. And they are becoming even more important day by day. The packaging industry needs change. It needs modernization. It needs digitalization and networking. And so there are a lot of topics that we have to deal with day by day. And you name them: the lack of skilled workers, IT bottlenecks, rising energy costs, and more topics like that. They certainly concern you all. And one of these big topics, energy, will be the main topic of today's event. To that end, we have a very broad range of interesting speakers today here. We have a keynote from Porsche Consulting. We have a voice of a German customer, a German corrugated cardboard company, and we have some words from colleagues of mine and myself. But we have another important role on board today. Let me introduce. This is Fred, and we will find out later what Fred is all about, because we will meet Fred later after our first keynote speech. But before we start, I have to tell you some rules, some important rules to make this event successful, some very strict rules. But don't be afraid. You can completely relax, just lie down, listen, and enjoy. We don't see you, and even the other participants can see you, so you really can be relaxed. There is no cam function at all. You are welcome to get screenshots of our event. So if you want to have any screen, just do a screenshot and get this. But you do not have to do this, because we will record the whole event and you can access this recording afterwards. If you have any question during our keynote, during our presentations, we want to make it possible for you to post some questions. For this case, use our Mentimeter. You can see a chat function in the lower right side, and there is a link in the chat. You just have to click on this link, and then you can enter your question. We will collect these questions, and we will answer them after the presentations. So I just tell you, please use this, ask your questions. We are happy to give you answers. If you have any technical problems, please just drop us a short email. The mail address you can see there, it's ulrich.peschke@openpack.com. Ulrich is sitting behind the desk. You cannot see him, but I can see him sitting there. He's eager to get emails from you, and he will help you immediately. The most important rule for today, for sure, it's enjoying what we have to show you, what we have to tell you. And for this, we have sent you a bottle of wine. And that's our most important and the first rule. So take your bottle of wine, take a glass, and enjoy the wine and listen to what our presentators have to say. I say cheers, and I wish you a good time with us. This now leads me to our first topic, our first program point for this evening. I'm very proud to welcome one of the leading German consulting agencies I'm proud to welcome Porsche Consulting. We have two guys with us. Welcome, Kevin Lin. He's head of AI and data analytics, and he's a guy from Taiwan who knows Edward Snowden personally. And also a warm welcome to Fabian Schmidt, associate partner AI and data analytics at Porsche Consulting, and he's the first German champion in the fastest growing sports in Germany. It's paddle tennis. So welcome, both of you. They will tell us something about decision making. The title of their keynote presentation is How Do I Make Better Decisions? The Use of AI and Data Analytics in Production. Kevin and Fabian, I'm happy to have you on board today. The stage is yours.
Yeah, also welcome from our side, and thanks a lot for the introduction. As mentioned, we're going to focus in the next 15 minutes on how to use AI and data analytics to make better decisions in business environment and to generate impact. And I mean, I think all of you have read statements like the one on the left side. Information is the oil of the 21st century, and data analytics is the combustion engine. I think there's something everyone knows, that there's a lot of potential in AI and everyone is somehow investing in first use cases, but the reality looks completely different. So there are plenty AI projects, but only about 15% from a statistical perspective deliver any business impact. And on the other hand, the complexity is increasing and the increasing speed of change requires faster and more effective decision making. So actually there is a huge gap which needs to be closed. And this is where we are working on. And in general, from our perspective, there are 4 guiding principles that you need to take into account to generate impact with AI. And all starts with the right expectations. So it's about setting the right realistic goals and choose cases which are solvable with mathematics and algorithms. Classical example, you want to do predictive maintenance for one of your assets in the production line, which has never failed before. I mean, if this never happened, this is like predicting an airplane crash. So almost impossible because there's no history. So it's really about differentiating between science fiction and science. And connected to that is to set the right focus. So really come from the most expensive decisions in the company instead of creating isolated use cases based on the available data. And then third one, of course, you also have to select the right approach. So often if you choose classical black box algorithms like neural networks and so on, there is really difficulty to get the acceptance with the workers, because in the end, you normally don't trust something that you cannot understand. So we highly recommend to apply crystal box algorithms to combine the strengths of both sides. So the experience of human beings and the power of AI and data analytics. And last but not least, of course, it's also about the setup. So often AI and data analytics projects are driven by IT departments, but actually it should come from the business and the process owners to define the topic. And then in the end, you have to connect all relevant stakeholders. So process experts, data experts, and of course, to get the buy-in from the management team as well. And to go a bit deeper into what I've just mentioned, I mean, most use cases in terms of AI are ones like you can see here described as go deep use cases. So you have one robot, you take like 1 million data points and try to foresee when this robot's going to fail. And if you know, okay, with a probability of 70%, the robot will fail tomorrow at 3 o'clock, I mean, at least you can send someone to wait for it and repair it quickly. But do you really solve the business problem at this point? Definitely not, because the real question would be, why do all my robots fail over and over again? And really get to the root cause to improve the robot and the asset availability. And this is what we do. We would mirror the complete value chain, really identify based on that heterogeneous data drivers for downtimes and resolve them. And I mean, the main difference is then it's not an individual separated use case anymore. It's an end-to-end platform approach, like also openpack is providing with their solution. And you don't necessarily need large amounts or millions of data. Sometimes heterogeneous, high quality data is enough, and you have a way bigger impact on the overall business KPIs. And by doing that, you can also identify the right spots where you can go more into detail to establish so-called go deep use cases as well. And one method we are applying to do that is called causal AI, and I would like to hand over to Kevin as a leading expert in that area to give you some insight what it's about.
Thank you, Fabian. If you look at this slide on the left-hand side, this is the Gartner hype cycle for artificial intelligence from 2022. And so last year, causal AI made it to the Gartner life cycle. And according to the Gartner cycle, is still in the beginning. So many people will ask, what is causal AI? I think the first step is to pronounce it right, because lots of people, when they look at it, they say it's casual AI, but it's not. It's causal AI. It's focusing on causality. So this is the basic, the most important point, what causal AI brings it. But why do we focus on causality? If we look at the AI algorithm, how does AI algorithm interpret the world? It looks at the world through the lens of data that we give the algorithm. So it has a limited scope, but we as human, we've been living here on the earth for over, let's say for me, over 40 years. We have other sensories. We observed a lot of relationships. We observed a lot of causalities, dynamics in our 40 years of lifespan. And now we have a different understanding of the world, and we could actually challenge the AI modeling. We can actually teach the AI to say, okay, this is right or wrong. Because AI, most of the time, it could only figure out the correlation. In statistics 101, everyone knows how to say causality is a correlation is not causality, but nobody really actually says what is causality. But we do know that mixing the causality is going to have a very, very huge impact. For example, if an AI algorithm gets a data set depicting the ice cream cells and the number of victims of shark attacks, the AI algorithm is probably going to see a positive correlation and say, oh, okay, so when I observe more ice cream cells, there will be more people who are attacked by the sharks. So if we make this correlation as causality valid, and we say, okay, now our target is to reduce the number of shark attack victims. What are we going to do? We're probably going to reduce or forbid ice cream sales. But is it the correct measure? It's not, right? So this is a very, very stupid example saying how stupid the application of such levers are. But if we put the joke aside and think, in our daily business, in corporate context, how many times these kind of decision has been made to solve corporate problems, then we are going to get the idea why we need to focus on the causality in order to get the proper levers. So if we look at the right-hand side of the slide, you're going to see this is a so-called causal network. And every dot in this network is a variable explaining, for example, seasonality or number of shark attack victims or ice cream sales, you name it, all kinds of variables. And the linkage between them with the direction, they are depicting the causality direction. And if we have this modeling approach, what is it going to bring us as an advantage? And first of all, of course, we can have the proper model of the physical world, telling us how the world is really working. And the second thing is, then we could actually use the causality direction and figure out what is actually the root cause to understand it. And the third thing is, once we understand, once we figure out what is the causality, and we can implement measures. And if we want to implement measures, we want to know what is so-called best bang for the buck, right? So we want to have the minimum investment and have the highest impact. So we will be able to quantify different levers and say, okay, this is going to cost me this much, but this is going to also bring me this much profit. So we can quantify it and make educated decision, quantifiable decision. And when we combine these two aspects, we look at the AI model, and then we get a human expert into the discussion, modeling the whole approach. And we're basically combining artificial intelligence and human intelligence. And this is what we call a super minds, because we as human, we need our algorithm to deal with repetitive, complex works that we actually don't have the time or the speed for that. So if we understand all these plus points for applying causal AI, then we're actually going to be able to generate sustainable impact for the operation. And I'm going to give the mic back to Fabian.
Yes, and to show you that it's not science fiction, we also brought one of various examples that we've done already at Porsche Consulting, where we applied causal AI in projects. And this is a really interesting one in a corn seed production. And they were facing the challenge to reduce their production losses without investing in new equipment. And actually, the first step was, of course, understanding the physical process. So there was a harvest process, receiving area, conditioning area, and of course, process like production control and asset maintenance. And what we've done then is to mirror this physical world into the data world by collecting all those data points you can see on the picture. So like ERP data, motor current, speed, line allocation, and so on. And I mean, this is the hard work to pragmatically connect all those data silos and close gaps and enrich them with human know-how. But once this is done, of course, the magic starts. And this is the point where we took we used a causal AI network to ask the question, what are really the key drivers for the production loss in that system? And then it pointed out exactly those 3 red points. So one was, okay, you have to put certain types of corn on certain production lines. There's one lever to reduce this. Then it's the speed, how you feed a certain asset. If you keep it in a certain range, another big benefit. And the third one, you have to control the moisture of the harvest in certain areas. And by simply selecting those 3 measures, there was a saving potential behind it of 10 million euro over 7 plants. And what it showed us, I mean, in the end, it was just a 6-week project to identify those topics. And we figured out topics which never came up if you do it with manual methods, just due to high complexity. But of course, this is only one specific challenge that can be tackled with AI and data analytics. There's way more. And here are a few examples of burning questions you probably are facing over and over again. So for example, how can I increase the efficiency in my factory? So by providing data-driven transparency and better decision-making. Or the burning topic of increasing scarcity of resources. Of course, you can also apply advanced tools to optimal, dynamically, and efficiently allocate those resources. And last but not least, also the question, how do I balance cost savings and sustainability within the factories with a data-driven energy management? And you're gonna hear more about it in the openpack presentation later on, but of course this is a really good solution to provide database benefit also in those areas. And last but not least, I mean, what's really important in terms of those projects from our perspective, it's something which is important for us as a consultant company, but also for all of our clients. It's to really combine industrial experience with analytic skills. And we always use this comparison of James Bond and Q. So you need the James Bonds who can generate impact, understand the business, understand clients, and also ensure the decisions are getting executed. And on the other hand, you need the Q who can generate insights, understands data, and provides a good decision basis. And the closer they work together and the better they stand each other, the better the result will be. So our data science and our teams are somehow hybrids who are also able to understand business and have experience working there. And I think this is key in all those projects that you're building those mixed teams. So that's it with the presentation from our perspective. And then, of course, we are very happy to answer all your questions.
Thank you very much, Kevin and Fabian, for this interesting keynote presentation. We already have the first questions from the auditorium. Kevin and Fabian, I would just read the questions and I would ask you to answer them. I will just start with the first question. The first question out of the auditorium is, what added value does causal AI bring to companies in contrast to other common AI methods?
Well, I think I'm going to take this question. I think the major point is that you make sure that the AI result is based or is valid, is based on the reality, is based on the real dynamic or real causality of the world, instead of saying, okay, as long as the model fits, it's working correctly. But once our environment changes, our data set changes, if we go by traditional AI approach, we're probably going to have a complete different model dynamic. But if we use a causal AI, the fundamentals, the dynamics, they stay the same because it's how the world functions, how the world works. And the only thing changes is just the data itself. The model structure is not going to change. So it's going to save you some time understanding the topic, building insights into your own asset, into your own operations. So I think just based on the knowledge accumulation for a corporate environment, causal AI is more like a library for you to use and not just a band-aid to stop some minor injuries on your hand or something. It's really building up your company know-how and competencies.
And maybe to add something, I think
Kevin,
it's
thank
also,
you. We have
maybe some.
We have another question.
Okay.
We have another question from the auditorium. In your view, what is the most important to do for companies to be AI ready?
Well, yeah, this is actually a very, very big topic where most companies are not really putting any much focus on it, because based on the, let's say, top management behavior, a lot of times when a new technology comes, like currently GPT-4 and all that, all the companies are saying, okay, I have to do this, I have to do that, I want AI to be able to solve my problem. But AI thrives on data. You need to feed data to AI. And most companies are actually not really putting a lot of focus on data governance. We talked about data owners. A lot of people say, yeah, I'm the data owner of this data. But what is the job of the data owner? What is the responsibility of the data owner? The data that he's responsible for, is it really clean? Is it going to be measured by the data? Because if a company has all the data already in place, then applying AI is just putting an algorithm on it, run through the data, right? So I think the most important step is do your data governance right to make your corporate data usable. That is the most important part, I think.
Thank you again, Kevin. We have a third question. Can AI really determine causality, and doesn't it require a lot of human knowledge?
This question is correct. I mean, the algorithm that we use, it could guess the causality, but if you look at the whole network that we just showed, there are a lot of connections. If any node at any point, any dot has been connected to every other one, we have a lot of connections. So the algorithm is going to figure out the connection and figure out what's more important, what's not important. But the reviewing part, you still need human to verify if the major causality directions are correct, because the AI algorithm pulls the more important variables closer to your target variable, closer to what you really want to figure out. And then you can focus your discussion, your subject matter expertise on correcting those close variables, their causal relations to each other. So you don't have to deal with millions of causal relations within the network. So this is the advantage that an algorithm does, but still the verification, you need human to have the final stamp on it and say, this is correct.
Great. Kevin, thank you again. That's it. Thank you for the presentation to Fabian and Kevin, and thanks also for answering the questions. We will continue with our presentation now. I want to show you a little bit more about openpack in general. And when you remember, we had one very important role at the beginning, and this role was Fred. And Fred is back. And let's hear what Fred has to tell us. My name is Fred N. I am the best traffic light in town. I'm modern, I'm optimized, I'm the nicest traffic light. I've got the greenest green, and I always show green lights, and my green is the brightest. Where does my name come from? Well, that's simple. Fred N stands for Fire Red Never. And the best is, I'm getting better each year. I'm getting nicer, I'm getting greener, I'm getting better. But is Fred really the best traffic light in town? Well, Fred does his best every day. But despite being so green, so bright, so modern, Fred doesn't produce what he's supposed to. He falls short of his potential. And this is the result. Fred has forgotten something very important. Fred is not alone in the city. There are other traffic lights, and the users of the street, the car drivers, the pedestrians, etc., they do not love Fred. They want to drive smoothly. They want to drive quickly and safely. They want the whole system to work properly, not just one traffic light. Fred understood, but what could a solution look like? He was pondering desperately. He was thinking about this. And after nights, sleepless nights, and many, many thoughts, he came to a solution. He wanted to become even more modern, even more complex, even more professional, something like this. But this also did not work. This was not the solution. No. The real solution for Fred and the whole system is networking with others, networking with the other traffic lights. It's coordination of signals, it's inclusion of all the participants, and it's also including the cyclists, the pedestrians. And suddenly, Fred was no longer just the best traffic light in town, but traffic in the whole city was sustainably optimized. But what does that have to do with the corrugated industry? Well, it's quite simple. We know a lot about single machines that are trimmed to the maximum, that are optimized more and more, but they do not take care about the whole production and the whole value generating process. And this is exactly what openpack and the openpack vision is standing for. We want to make packaging more productive. And we do this by connecting all the participants of the industry, and we enable them to speak to each other. So we create a common language. We do a standardization of the data. And as a platform, we enable the usability of all data for all the systems in a plant. We digitalize all activities along the value chain, and we simplify, accelerate, and automate processes. In one word, we increase the productivity of the whole system, and that means we increase the productivity of all the participants. How does this look like in detail? For connecting all these participants, openpack provides a so-called openpack hub. It looks like and it works like a giant power strip. It's just a technical framework and an architecture where all the existing solutions can be plugged in. For example, existing machines in the plant, existing systems like an ERP, a planning system, a reporting tool, and many, many more. Jack. Openpack does not want to replace these solutions. We just enable these systems to be plugged in, to exchange data and get data and become even better. But in these big views, you can also plug in some new openpack solutions. For example, the digital factory, the e-procurement solution, and our energy module called resource control. We will tell you in detail later on. But you can also plug in new solutions. There is room for a lot of partner solutions which you can easily install and connect, just like you're using your smartphone and installing an app. And if there is a case that data does not really fit, there is not a fitting connector, then we can provide you with fitting adapters. They are developed by our partners, and you can see one of these adapters on the right side of the plug. So when we're looking at the openpack portfolio in a whole, you will see that by plugging in these systems, we enable all these players to exchange data, and we connect them, we standardize this data, and we also share the data to provide better solutions for all the participants. In a nutshell, the openpack portfolio consists of two basic groups. The first, I already showed you, is the openpack hub. It's all about data. It means data reception, standardization, and transferring or distributing the data. In that case, openpack acts as an enabler for all the users and partners. The second group of solutions are the own platform solutions created by openpack. It's, as I told you, the marketplace, the resource control, and the digital factory. They are all for different target groups, and it's all about making purchasing easy by collecting all the suppliers on the marketplace. It's about reducing energy costs when we're talking about resource control. And it's about increasing productivity when we're talking about the digital factory. In that case, openpack acts as a solution provider for you, the users. One of these own openpack solutions, I'm very happy to introduce you. We want to show you this. And for that reason, I have a colleague on board, Pat. The stage is yours. I'm happy to have your presentation about resource control.
Thanks, Stefan, for the introduction, and welcome to everyone participating today on the Digital Day. Yeah, as Stefan already mentioned, I'm honored to present to you one of the modules we provide to you as a user of openpack, and as we can see here, it's dealing with a very hot topic currently. It's about resources and energy. So In the last 2 years, we all recognized the development, which was not very nice on this topic. So we all experienced an intense and a very dramatic increase in the prices. Here we can see on the slide only the second half of 2022. So the prices in all Europe increased dramatically. But this is only one side of the coin. The second side is that also there is coming up more and more pressure and more requirements from politics. So also the European government is increasing the pressure on producing companies to deliver more transparency, to be more sustainable with resources, but also the brand owners. So the Adidas and Apples in this world are setting pressure to the suppliers because they set very strict sustainability goals, and therefore they want to become climate neutral, for example, by 2050. And therefore you as a supplier need to be more transparent on how you use your resources, how you can decrease the resources in your production. So this is also setting more and more pressure on you. This is leading to different issues we identified as openpack. So of course, on the one side, we have the rising energy costs and the increasing environmental regulations you have to deal with. But also this topic came up very, very fast, and a lot of the companies, the producing companies, are not equipped in a way that they can deliver such transparency. So there are not that many sensors installed in the plant. There's a lot of manual effort to get this information. So there's monthly reading of the energy meters, which is then also causing that the consumptions cannot be allocated to the specific production orders, to the specific machines. So here we just have a problem to provide this transparency. And therefore, it's also difficult to implement ISO 50001 certifications or EMAs. So this is very tough to get, and there is often a lot of manual effort with it. But what can resource control offer, and how can openpack help you with that? It's basically 3 points. On the one side, we can provide you with an overview of all the energy sources and the consumables that are used in the plant. And therefore, we can also identify potential savings within your production process. Due to this overview, we therefore have also options within to have easy analysis of the data. You can run different analysis based on pre-set up KPIs. You can create your own analysis here. And which is a very important point, you can also link it to order and machine data to have much more deeper analysis. So, for example, we can answer questions like, can I run a machine at, for example, only 80% of the speed, and therefore also decrease the intensity of the infrared dryers so that I can save a lot of energy here and then be more profitable on the specific order. Or I can also compare different or the same order in different runs. So how was the order performing the last times and now? So I can recognize changes here. And the third one, of course, due to the other two ones, we can save labor costs. So we can decrease the amount of manual effort dramatically. The reports for the customers, for sustainability reports, or even for audits like for the 50001 certification can be done with one click out of the system. You have all the information combined to your production orders to your machines, and can therefore provide increased transparency here. But let me complete with these slides. I can directly show you how this is looking like in our system. So therefore, I will share my screen give me 1 second here. So let me share it. Yes, okay. I hope you can see it. When we log into our system, so what I'm doing is I'm logging into our live production system. As we can see here, we will have a look on a demo plant we have created. So this is no actual customer information, customer data. But when we log into the system, we directly jump to our cockpit, which is the landing page of our platform. And there you can see all the different applications you can use as a customer. You have different recommended services from all our partners. But what I want to show you is basically the digital factory. The resource control module is based on the digital factory. It's an add-on. So when we jump into the digital factory, we directly can see the 3D bird's eye view we create for our customers. So here we create a view which is directly representing the shop floor at the customer side with all the different machines, the storages, the intralogistics. Yeah, so that's basically the view. Here we can see we now are in the production layer. So when I'm hovering on one of these green colored dots, then we can see how the machine currently is performing. So we have production information here regarding the speed, the average speed, target speed, which board grade is currently produced here. We also get first information on the stops, so how many stops have been occurred on the machine, how much production time and stop time is there. But here I don't want to go into deep. If you want to have a presentation here on all the different functionalities of the digital factory, just contact us. We can do this in deep with you. I want to jump to the resources layer. So we set up a second layer on our 3D bird's eye view. And here we can have a look on what is the machine currently consuming in terms of energy. So we have the consumption overall of today in kilowatt hours. We have also the live power consumption of the machine. So we have the kilowatt here, and we also can compare it with first production information, like for example here at a flatbed die cutter, we can compare it with the consumption of 1,000 sheets of this day and have here a first indication on do we consume a lot of energy today, or is it not that much? And of course we can also jump in and have a more detailed look. So we can see here, for example, the electric power consumption of the machine in comparison to the speed of the machine, and can also identify first anomalies here. For example, here we have a downtime of the machine of around 20 minutes, and we see that the production was going down, to zero. So the machine stopped, but the power consumption decreased. So we almost used double the energy here. So this is something we can go for to have a more deep analysis. What was happening here? Was it due to the operators at the machine, or is there a problem at the machine itself? So here we can have a deep analysis. On the other side, we can also have more detailed information on which different modules of the machine have consumed how much energy. Therefore, I can show you a better example here, which is the corrugator. So here we can see how much energy has been consumed by the different assets of the machine, and we also have this consumption versus 1,000 square meter KPI within. So to analyze, to have a first indication on the energy consumption of today. Well, this is only the live data we can provide here. But of course, as mentioned, we can also analyze historic data. We can run reports, we can do dashboards here. So we can create our own resource management dashboard, as I can show you here. you can set up these dashboards by your own. You can use different pre-set up KPIs to do so. So here we have an example, for example, with the total energy consumption, total gas consumption, here, and also the total energy consumption. We can then see how is the energy consumption split to the different machines. So we can see here the corrugator is the most consuming machine today. And then we can also go again into more depth analysis, like, for example, the power consumption versus speed. We can show the different power consumptions of the different machines here. We have an inliner, we have the FFG within, and the flatbed die cutter, to have a comparison how the machines behave, and, for example, here the conversion. And of course, we can also show the total power consumption of the whole plant. So what we can do here is we can identify peak loads for the whole plant, as you can see here. In comparison to the rest of the day, there are specific peaks within, which is also or which can be an indicator or a factor to the energy prices you're paying. So this can be done very, very easy. And of course, you can also change here the time frame you want to look at. So we can also change it to yesterday, reload the KPIs, and then you have the power consumption for yesterday or for the last month, for the last year. So this can be done very, very easy. As mentioned, you can also use this information, these KPIs in reports. So you can create your own report here. You can create it as a PDF. You can create it as an Excel or PowerPoint, or you can even create a report series where you automatically get an email with the PDF, with the Excel file attached. And you can also add the colleagues you want the report to get. And can select, of course, when shall they get it. So, for example, every Monday morning at 8 o'clock, with all the information of the last 7 days. So you can then also use it for meetings or, as mentioned, for the different reportings you want to do. Okay, so one of the last features I want to show you today is our condition monitoring feature. So we implemented a functionality which makes it possible to analyze all the different variables, all the different information we get from the production, not only from resources, but also from production information, and then set some conditions which shall be automatically triggered when there's a specific incident happening in the plant, and then you get a notification as a user. You can see here you get notifications directly from the system that, for example, here a rotary die cutter is producing 20% slower than the target speed. And also you can send these alarms via email to you or to your colleagues. So let me show you one of these, which is a good example for our resource topic today. So we set up here for our demo system one alarm, which is dealing with the inliner. And here it says we have a high energy consumption despite there is no production since 60 minutes. And when we have a closer look here, the condition is that there is an energy consumption power consumption over 100 watt hours as soon as the machine is in a current state of idleness. So there's no production plans since 60 minutes. Then you can send an email to one of your colleagues, to an operator on the shop floor, which says, okay, please turn off the machine. We have energy consumption here, which is not necessary. So we can save money very easily. Of course, you can also do this with production data. You can say, I want to get an alarm if the machine is in a downtime for example, 10 minutes or 15 minutes or whatever. So you can really give alarms to your operators and therefore be faster in resolving such issues and such problems in the production. Okay, that's it in short. I shall jump back to the presentation, I hope. Let's see. Yeah, okay. So overall, what is the value add for you as a customer? First of all, you get more transparency in your resource consumption. We can give you an overview of all the different resources. We connect different sensors that are already installed in your plant. If there are more sensors necessary, we can do this with our partner network. So we have partners that provide this service to install additional sensors and then also provide this information to openpack. So there's no effort for you. As we can see, we can do anomaly detection here. So we can see if the machine speed is staying the same over a specific time frame, but the energy consumption is rising, or the power consumption is rising, then there could be a problem at the machine, and we can inform, due to our condition monitoring, the different guys, the maintenance guys or the operators at the machine. We can detect unnecessary energy consumption and therefore save money easily. Yeah, we can recognize and therefore also avoid in the future peak loads in the plant, as we can have an analysis of the whole power consumption of the plant, and we can support with our dashboards, with our reports for the certifications based on ISO 50001. We can compare different orders with our KPIs. So this is very flexible. This is very easy to use. Yeah. Our focus is not on one specific machine, on one specific OEM or supplier of a machine, of a system, but it's basically the entire factory, and it's all machines of all manufacturers. So it's not all only energy consumption, but it's also gas. It will be compressed air, it will be water, and it will be steam. So we're dealing with all the different resources that you consume in your plant, so that the most important one, let's say, and yeah, that's it in a short to the resource control.
Thank you, Pat, for this wonderful short presentation. In a nutshell, that's it. I already have some questions from the auditorium, and I would ask you to answer them. I'll do it the same as we did with our Porsche colleagues. First question is, can I use resource control on any device? I think this is regarding to the hardware, where you can see and use the.
So basically, our platform openpack is a web application. So this makes it very easy to use it on any browser, on any device. So it's optimized also for smartphones, for tablets. So you can use it anywhere, anytime, from any device, let's say.
Thank you, Pat. The next question. Do you plan to include other resources like steam or water or compressed air in the module?
Mm-hmm. Yeah, we do. So as just mentioned, we currently have energy consumption and also gas within, but we extended to compressed air, to steam, to water, so which is the most important resources we have in such a factory.
Then the next question, what is the connection process and how long does it take?
Mm-hmm. So basically, it's very individual on every plant. What we do is, if you as a customer decide to use resource control, we come to the plant, we have a look on what is already there. So some of the plants already have installed some sensors on electricity, on compressed air. Then we can use this data. We can connect these databases where you have stored the information, And if necessary, we can also work with our partners. So we have some partners which are providing the service to install new sensors, and then also provide the information to openpack. So it's really depending. The sensors which are there, we can connect them very, very fast in a couple of days and weeks. But of course, the sensors that need to be installed, it's depending on the service which has to be provided by the partners.
Thank you, Pat, for the presentation again and for answering these questions. Thanks, and I will directly hand over to our main guest for today, because what could be more important than the voice of a real customer? And I want to hand you over to Karl Eichhorn, to Martin Keitrath, who is the managing director of Karl Eichhorn and who is already using resource control in his plant. Martin was presenting the slides 2 weeks ago in our German edition. Unfortunately, he cannot join today, but therefore I want to introduce you a new Martin Keitrath. And he's Robin. He's from our team, and we asked Martin if we can use his slides, his Karl Eichhorn customer slides, for the presentation today, and he agreed. And therefore, Robin, I'm glad to have you on board, and the stage is yours.
Thank you, Stefan. Yeah, of course, it's a pleasure for me to present to you the field report created by Martin Keitrath, Managing Director of Karl Eichhorn. Yeah, he asked me to take over today, and for sure, I'm happy to do so. Just some words about Karl Eichhorn company. Yeah, it's of course a German company. Look at the name, and it's really a company with a long history. In 2 years, they can celebrate 170 years anniversary. And it's still managed, family owned, and the 5th generation is managing it now. Accordingly, the core values, they want to combine the future with the tradition, staying innovative, as well as to offer personal interaction with customers, partners, and colleagues. Some numbers about the company: with 250 employees, they produce roughly 180 million square meters of corrugated board in 2 plants. A third one does folding boxes, and the 4th one takes care of forwarding and warehouse logistics. So they achieve 85 million euros in sales, mainly in Germany, Netherlands, and Belgium. 2 out of their 5 mission statements emphasize investing in modern equipment and solutions, as well as working sustainably to expand the organic growth in Central Europe. These statements underline Eichhorn's digitalization strategy, which is the basis for their consistent implementation of that mission statement. Eichhorn is quite modern positioned, but has some lacks in maintenance and operations. Coordination between operations, order entry, and machines is highly automated, but the surrounding areas show room for improvement. And that was the motivation for talking to openpack. So the initial situation was that openpack presented their solution in 2020, and after agreeing on the conditions, they started implementing the openpack digital factory in both corrugated plants. So the 3D view of production was finalized in 2021. This is the original setup digital factory 3D view of the plant in Kirchberg, including external warehouses with all data like shown in the live demo by Pat. The 3D view was added 2021. The time before there was not much available in digital format, so all circuit diagrams, operating manuals, etc. were scanned and digitalized to be ready for use in openpack. The reason and obstacles why they really decided to extend the digital factory by resource control was having the production overview with the digital factory. Eichhorn was looking for extending these views since they did not have a live view of their energy consumption. Electrical power and compressed air consumptions, for example, were checked once a month only before, and therefore could not allocate consumption in detail. Reporting was done manually and a quite time-consuming work. So it was not really possible to identify optimization potential based on live consumption facts. Problems with compressed air, for example, were recognized 4 weeks after they occurred. The same applies to anomalies in energy consumption, which could not be recognized. Everybody who runs a corrugated board plant knows the situation, that a machine doesn't run, but compressed air consumption raises immensely, and you recognize that 4 weeks later only. So which measures were taken to implement resource control? At first, connection. For removing these obstacles, Eichhorn exchanged the classical power meters by digital ones to overcome the brownfield connectivity with the support of openpack partners. Now it was easy to visualize the live and historic power consumption in resource control and put it into correlation with production speed, etc. To analyze the consumptions, the integration of all machine and systems data is key. But that integration, condition monitoring can be implemented, and warnings, alarms, and others can be created to inform the responsible colleagues. Freely configurable reports can be created automatically and sent by email to appropriate colleagues on a time-controlled basis. We even need more of these dashboards, Martin said. For example, how much energy is needed for a specific article's production, especially with rising energy costs. So what was coming out of these actions? Results number 1, resource control now shows live the consumption of electrical power in the plant. A drill down option shows in real time the produced article, order, speed, consumptions, or even KPIs like power consumptions versus production speed, or power consumption per period, per 1,000 square meters, or per 1,000 sheets. The reporting function allows automatic creation and distribution of reports via email. Also, creation of templates for audits now is automated and avoids manual work. Results number 2. That's about what are the approaches for energy savings. Eichhorn sees potential in peak load and compressed air management. Especially having live information of the compressed air consumption enables to identify problems in time and reduce it. Especially condition monitoring shows the saving potential. Hardly you can discover when a compressor consumes double the average electrical power without the machine running. An individual alarm in that moment to the responsible colleagues allows problem solving. That's the best hint to save money. What have been the experiences and the outlook of Carl Eichhorn dealing with openpack? Eichhorn experienced the openpack team as pragmatic and with a step-by-step mentality while implementing the coordinated digitalization strategy. Martin Keitrath, as managing director of Carl Eichhorn, quoted, "The quickness of the implementation of the measures was impressive. I generally experienced the team behind openpack as fast, solution-oriented, and powerful." With that statement, Carl Eichhorn decided to extend the openpack installation to compressed air, what they implement actually, followed by water, gas, and steam. Comparing orders and machine performances between plants will show more potential of optimization. The next big step will be the connection of their maintenance software with openpack in autumn. That will give Eichhorn high potential of automation. Faster, more precise, and also ideal cycles in machine maintenance saves money. That's because they can measure real machine running times for maintenance turners instead of fixed time frames. So that brings me to the last slide. I am happy to hand over best greetings, best regards from Martin. Next time, he hopes to attend again the live meeting. Thanks for your attention.
Cool. Thank you very much, Robin. I think you did a very good Martin Keitrath. So I think we do not need him anymore because I think you replaced him very well. Robin, there are also some questions out of the auditorium, and I will do it the same way as I did with the others. I just read it. How long did it take to roll out resource control, and how much internal capacity was tied up?
Yeah, good question. I think if you prepare these kind of projects, this is most important. We expected around 10 to 12 weeks, but in the end, openpack was able to do it in 8 weeks, meaning this was the first 3D view of the plant in Kirchberg. And our own capacity was, in that time, around about 2 weeks of one IT colleague. In summary.
Thank you, Robin. The next question is somehow related. Let's see in the answer. The question is, in the industry, it's common experience that there are many deadline delays. How was the schedule reliability on the part of openpack in this project?
To be honest, it was vice versa. openpack was really pushing our project, and whenever we had some delays, it was more or less on our side because our IT guys were really busy. So we have been very happy with the demanding activity of openpack, and in the end, you see the short implementation time. This was their point with us together.
Cool. So there are no more questions left. Thank you, Robin, for taking the part of Martin.
Pleasure.
So, ladies and gentlemen, this leads to the last program point for this evening. It's once again saying thank you to all the presenters today. It's also saying thank you to the auditorium for joining us this evening and also for posing these interesting questions. Thanks again to all of you joining us. I hope that we could provide some thoughtful input for you. If there are any questions left from your side, it's very easy. You can just come back to us and ask the question directly to us. Contact us. We are happy to help you out. We are happy to present you the whole solution. And we are also very happy to meet you on the site, so in your plant, to see your surroundings and see your options we maybe have at your plant. So the last point for today is, again, saying thank you. I want to raise the glass for a last time. So enjoy your wine, have a pleasant evening, and I say goodbye, servus, and bye-bye. Let's get it out. Cheers.
Cheers.